The bicycle is the most efficient mode of transport ever invented. 99% of the effort put into turning a pedal is transferred to movement. So the lighter the bike, the better. Using cutting-edge materials, a high-performance seat can weigh as little as 5 ounces. This company made a special seat for a past Tour de France winner. In fact, half the cyclists on the prestigious Pro Tour racing circuit use their seats. The design process begins with the simplest tools, pencils and paper. Designers sketch out a few basic ideas. Specialists then transform the sketched ideas into 3D digital images. The manufacturers machine model those images into a prototype. After testing, they begin the manufacturing process. A worker places a base or shell on the upper segment of a mold. This company makes their shells from a variety of carbon fiber materials. Polyurethane pours into the other section of the mold. This is the part of the mold that will give the seat its shape. When the mold closes, it cooks at a mere 104 degrees Fahrenheit. A chemical reaction takes place inside the mold, which causes the polyurethane to expand. 5 minutes later, an operator removes the seats from the molds. Here we see what the shells look like before and after. A worker removes excess polyurethane from the edges with a knife. While the polyurethane cures, workers prepare the cover material. The material is a proprietary microfiber specially made for this company. Not only does this material need to be flexible, waterproof, and comfortable, it has to be incredibly durable. Once they've cut the material into strips, the workers stack them on a stamping press. A die has been custom made to match the design of the seat. The stamping press descends with enough force to cut through multiple layers. It's now time to join the 3 panels of material that make up the seat cover. This facility has 2 different methods for attaching the pieces to each other. In this case, a skilled worker carefully stitches the material together. A different method of joining the panels involves a process called thermo-welding. An operator skives or thins the edges by shaving them, so that there won't be a bump where they overlap. Double-sided tape will hold the material together. A special tape dispenser applies the tape to the skived edges. A worker positions the panels, carefully overlapping the edges. A vacuum system removes air from between the top and bottom sections of the press, holding the panels in position and ensuring there will be no bubbles at the seams. The press then heats the material up to 280 degrees Fahrenheit, ensuring that the adhesive bonds the panels together. The design of the shell for this seat has several slots in it to help create the right combination of flexibility and rigidity. A laser machine cuts stripes in the cover fabric to create a graphic element that reflects this design feature. Workers glue silver material under the stripes to highlight them, then brush glue all over the underside of the cover. Mounting the cover on the seat requires 2 operators. They place the covered glue side down on the seat, ensuring that it's positioned perfectly and that there are no air pockets. They work the cover into a small recess that runs around the perimeter of the base. They will then trim off the excess material with a utility knife. The amount of skilled manual craftsmanship required to build these seats is a key feature of their quality. But the company also relies on state-of-the-art technology. Bicycle seats sit on a framework called a rail. This facility makes rails from both carbon fiber and metal alloys, and it tests each one with the dynamometer. Workers put glue in the attachment points on the bottom of the seat to ensure that it passes a stringent safety test. A customized machine bends the seat to fit into the rail. The seat will then be bent back in the other direction to return it to its original shape. The seat is now finished. Fusing state-of-the-art technology with skilled craftsmanship, this company makes 520,000 bicycle seats every year.